let's start with the next topic, that is, you can say, the types of the supports, right? So in this class we will discuss the types of the supports, right? So what kind of support is there, right? So the support connections are there, right? So how to connect the two members, right? Say one is, this is one of the member, right? So that is one of the members, right? So these two members are required to be connected together. So those can be connected by a, one is there is a pin supported connections, right? So that is a kind of a metal connection, right? So these two members, this is one of the member, this is second member. So those two members can be combined with the help of these number of pinned connection, right? So that is a pin supported connection. That is a kind of a metal connection. So this is the front view of that pin connection. So in this way, so number of plates are attached to join the two number of I section, right? So this is say one of the I section, right? So this is the second I section. So those I section are can be joined together with the help of a pin supported connection. Further, so again, I section is there. So second I section is there. So these two I sections are joined together with the help of a welding connection, right? So weld those two angles I section can be welded with the help of a welding connection, right? So that is a kind of a fixed support, right? So that is a kind of a roller support. That means there is a movement in the rightward direction or in the leftward direction, right? So that is a kind of a roller connection, right? So that ball represents the roller connection. Doesn't mean that there is a ball is provided here, but this is just a representation of the roller connection, right? So it is not to not compulsory to provide that particular ball, right? So in case of the structure, so these balls are not provided. Basically, what they do, they just rest that particular beam, this type of beam, it is rest over this kind of the column, right? So simply that means there may be a somewhat movement in this direction or in direction. So it may be adjusted itself according to the applied load. So according to the moving loads, right? So it can be adjusted, right? So it can adjust itself. That is a kind of a roller supported connection, right? So next type of the connection is, right? So that is a fixed support connection, right? So that is one of, this is say column is there, vertical member is there, say this is a beam, right? So that is a horizontal member is there. So those two members are connected together. Basically, those two members are casted, right? That means concrete is filled in between these reinforcement bars, right? So that means that member, it will act as a single unit, right? So that is a kind of a fixed supported connection, right? So we are talking about the support connections here, right? So I
Excuse
repeat,
me, sir.
pin supported is there, roller supported is there, then fixed support in case of a metal connection, that is a welding is there, right? So one is fixed support is there in case of a concrete, right? So whenever concrete is filled in between the space of say reinforcement bars, right? So these reinforcement bars are joined together, right, to act as a unit, right? So they both will act to counterbalance or to resist the number of forces acting on these members. In this type of a pin connection, right? So that pin is there, right? So that means if you apply the force here, right? So that pin can be rotate in the anti-clockwise direction, and it will be rotated about this point, that's pinned point, right? So whenever if you apply the load from downward in the downward direction, right? So what will happen? It can rotate in the clockwise direction, right? Further, so it cannot be it cannot be displaced in the vertical direction. It cannot be displaced in the horizontal direction, but it can only be rotated in the clockwise or in the anti-clockwise direction. That is a kind of a pin support connection, right? So that is a pin connected joint, right? So here, whenever a hollow circle, small circle is given in between two members, so that means it is a kind of a pin connected joint. Whenever no circle, small circle is given in between two members, say this is one of the member, this is one of the vertical member, this is one of the horizontal member, right? So in these members, we can say it is a fixed support. That means it is restricted in the horizontal direction, it is restricted in the vertical direction, and it is restricted in the clockwise or in the anti-clockwise direction, right? So here the fixed connected joint is there. So one is pin support, its pin connected joint is there. So it is a fixed support, so fixed connected joint is there, right? So a joint is between it, a joint is provided, say one of this is one of the member, say this is a second member. That means it is a fixed support, right? So it is properly fixed. It is restricted in all the directions. So this is say torsional spring support. That means a torque can be applied, right? So that torque can be applied in the say clockwise direction or in the anti-clockwise direction, right? So that is a torsional spring support. Say this is a torsional spring joint. Whenever this kind of symbol is given, that means the torsional spring joint is clear. So this is say actual beam, right? So say this is a say cantilever beam, right? So this is a point load, right? So this is a kind of a point load P, which is applied at say point C at the, or you can say a point load. That means which is acting at a single point, right? So basically, in actual, no exact point load is there in actual, but we just have to consider that point load, right? So why we are considering this point load? Because if say load say this is the load, right? So if a book is say this is a book, if a book is placed over a body, right? So you have to consider that the load of the book it is acting upon that beam, but in actual, so the overall load of that book it is supposed to be acting at a single point. And where is the single point? The CG of that book. It is the point where the whole load is supposed to be acting. According to that, we are considering the point load. right? So point load. So here you can say a span AB is there, right? So AB is a span of the beam, and a point load P, it is acting at the mid span, right? So it is acting at the mid span, right? How mid span is there? So half of the length is on the left side of the P, and half of the length it is on the right side of the P. In this way, we can designate that load as a point load. So next, I think we have to discuss the equations of equilibrium. I think that we have already discussed. That is, sum of forces in the x direction is equal to 0. Sum of forces in the y direction, that is equal to 0. And sum of forces that is in the z direction is equal to 0. Right? So that we have already discussed. Now we will have to discuss the stability of the structure, right? So we have discussed it theoretically, right? So to calculate the stability of the structure, right? So if we have to solve these equations, right? So we should have a number of equations. So those can be used to see the stability of the structure, right? So these are the equations of equilibrium that we have already discussed in the previous classes, right? So next is determinacy and stability that I am talking about. That is determinacy, right? So we have to see the stability of the structure, right? So we have to use a relation, that is R is equal to 3N. If R is equal to or less than 3N, that means the structure is said to be a statically determinate structure, right? If R is greater than 3N, that means we have to designate that structure as a statically indeterminate structure, right? So what is the meaning of determinate and indeterminate structure? So we are having a equations of equilibrium, right? So just listen carefully. We are having the equations of equilibrium. So if these equations of equilibrium are sufficient to determine the unknown forces acting on the body, in that case, we will say the structure is a statically determinate structure. Whenever these equations of equilibrium are not sufficient to determine the unknown forces, in that case, the structure is said to be a statically indeterminate structure. For that, we have to designate the structure as a statically determinate if R is less than or equal to 3N, or if R is greater than 3N, the structure is designated as a statically indeterminate structure, right? So what is R? R is the total number of unknown reactive forces and movement components. So number of unknowns, if the total number of unknowns, if it is greater than 3N, in that case, it is statically indeterminate structure. N is the total parts of the structure members, right? So whenever we will have some examples for the same, after going through those examples, you will be able to see. So let's start with say this is one of the, they are saying, let's start. They are saying uh, see uh, just see the statement. Classify each of the beam as statically determinate or statically indeterminate. Right. One is you have to identify the structure or that particular beam. Right. So whether it is a statically determinate beam or it is a statically indeterminate beam. Further, they are saying if it is a statically indeterminate, in that case, what you have to do? You just have to find out the number of degrees of indeterminacy. Right. So beams are subjected to external loadings that are assumed to be known and can act anywhere on the beam. Right. So let's start. So this is one of the beams, second beam is there, third beam is, fourth beam is there. Right. So whenever we will solve these problems, you will be able to know the determinacy. R is equal to 3n, R is greater than 3n, or R is less than 3n. Let's start. Say this is one of the beam, right? So first of all, we have to see the R. What is the total number of R? They are saying R is 3. How R is 3? So this is a pin spool. That means it can be rotated in the clockwise or anti-clockwise. It is restricted in the horizontal direction and in the vertical direction. So that means two number of unknown forces are here. So this is a roller spool. Roller means it can be rotated in the clockwise or anti-clockwise. It can be uh, moved in the horizontal direction, but it is restricted in the vertical direction. That means how many unknowns are there at this point? One. Total number of R comes out to be a 3. 2 here and 1 here. So let's use the relation R is equal to 3n. R is equal to 3n. N is total. N is total number of members. So how many members are there? This is one of the member is there. R is 3, that is equal to 3 into 1, 3. 3 is equal to 3. So if this is the case, whenever R is equal to 3n. So what is that means? It is a statically determinate structure. Clear? Next is, if you see this diagram, here it is a fixed spot. So whenever fixed spot is there, how many unknown reactions are there? So 3 number of unknown reactions are there. So 3 number of unknown reactions will be here. Further, one unknown reaction will be here, and one unknown reaction will be here because a roller spot is here and a roller spot is here. That means R is equal to 5, unknowns are 5. That is R is equal to 3n. R is comes out to be a 5, 3n comes out to be a 3. So that means 5 is greater than 3. So that means the structure is statically indeterminate. Now we have to find out the degree of indeterminacy. So degree of indeterminacy is 5 minus 3. That comes out to be a, it is indeterminate to the second degree. The beam is statically indeterminate to the second degree. So again, let's continue to the third example, right? So here the third example is there. It is a roller sport. That means it is not restricted in this direction. It is restricted in this direction. Further, it is restricted in the clockwise or anti-clockwise movement. That means how many unknowns are there? So two unknowns will be here. So this is a hinge sport. That means two unknowns will be here, right? So again, it is a pin connection. So that means two unknown will be here. So the value of R comes out to be a 6. But how many members are there? Now two members are there. So it is a connection in between two members. So one member is A, B, and second member is B, C. Now the value of N is 2. So 3N, that is comes out to be a 6 and is equal to 6. That means this kind of say beam, it is a statically determinate beam. Anything you want to add here? Students, anything you want to discuss? So again, here in case of a fourth example, right? So you can see in the fourth example, so this is a fixed sport. So how many unknown reaction forces will be there? 3 unknown will be there, right? So 3 unknown will be on the opposite side will be there. So 3 unknowns will be there at A, 3 unknowns will be there at B, 2 unknowns will be there at C point, and 2 unknowns will be there at D. 3 plus 2 plus 5 plus 2, 7 plus 3, 10. So R comes out to be a 10. How many members are there? 3 members are there. How 3 members? One member is A, C, second member is C, D, and third member is D, B. Right? So 3 number of members are there. So 3 into 3, 9. So that means it is statically indeterminate to the first degree, right? So that beam is said to be a statically indeterminate to the first degree. So again, examples are there. So again, we have to classify these pin connected structures as statically determinate or statically indeterminate, right? So I think all of you are can be able to solve these numericals, right? So you can see here. So again, a connection is there, right? So it is a fixed connection. So how many reaction forces will be there? 3. So here, this is a pin connection. So how many forces will be there? 2. 3 plus 2, 5. So it is a pin connection. So how many uh, forces will be there in case of a pin? So you just have to see. So doesn't mean so there may be a the diagram may be incorrect, but you just have to see. So i- is it can be rotate in the clockwise or anti-clockwise? Is it can be moved in the horizontal direction? Is it can be moved in the vertical direction? So from that you will be able to know what kind of restrictions are there and how many restrictions are there. So is the equations of equilibrium are sufficient to solve the numerical, right? So in that case we will be able to know the determinacy of the structure, right? So here the total number of unknown reaction forces are so 3 at A. So let's designate the joints. So this is say A, say this is B, say this is C. So at A, how many reaction forces are there? 3. How many reaction forces are there at B? 2. How many reaction forces are there at C? That means again 2. Right? So, sorry. Two are there. Right? So 3 plus 2 plus 2, that is 7. How many members are there? So here the two members are there. One member is A, B, and second member is B, C. Right? So two number of members are there, that is A, B, and B, C. So this kind of member, this kind of beam, it is statically indeterminate to the first degree. That means this 7, right? So minus 3n, 3 into 2, right? So that is comes out to be a 1. That means first degree indeterminacy is there. So again, we are having a same kind of example. So here the fixed support is there. So let's designate. This is A, say this is B, say this is C, and this is D. How many members are there? One member is A, B, right? AB is one of the member, right? So BC, it is one of the member, right? CD, it is one of the member, right? So how many restrictions are there at A? Two. Two number of restrictions are there, right? So because it is a pin connection. Again, a pin connection is there at B. So basically AB and BC are joined with the help of a pin, right? So pin connection. So therefore it is restricted in two directions, right? So this 2 plus 2, 4. So again joint C, again pin connection is there. So how many forces are there? Restrictions are there? 2. So 2 plus 2, 4 plus 2, 6. So how many at D point? It is a fixed support. So how many reaction forces are there? 3. So 6 plus 3 comes out to be a 9. 9 minus 9, that is 0. So we have to say that the structure is statically determinate structure, right? So students having any doubt in this class?
No, sir.
Okay. So that's all students for this class. If you are having any doubt, so let me know so that I can